It totally caught that. Hi. We're live. We're doing an after-school presentation. We are looking at math models with applications, and this is the worksheet, shape of things to come. Things that you'll need to complete this, you'll want some writing utensils. You're definitely going to want a ruler to draw stuff with. If you want to bust out the compass, because there's a couple circles to draw, that would be awesome too. You'll see me play with that in a little bit. So we're going to have a compass and a ruler to draw things to make it look pretty, and you're going to want a calculator so that way you can get to work on some of these items. All right, first one that we're going to do is letter A. We need to start with something that kind of looks like a square but isn't really. So we're going to start off by drawing something that kind of looks like a square. You want to make it big enough for you to draw all over, but not so big it takes up your entire sheet of paper and then you have no place to write. So make it look kind of like a square, but it's kind of not. So as long as the sides are straight, everything's good. All right, we're going to assume that these here are going to be right angles. So I'm going to go ahead and draw them in real quick just as an assumption. All right, now we're going to take some bites out of it because it wants that shaded region. And these are regularly shaped shaded regions. Oh, this compass is broken. Let me grab my other one. Emergency backup compass. I'm just setting the compass up.
Why is tacos the first word that always pops into my head even though I'm not hungry?
Hello. Hello. All right, so I'm trying to copy the picture that's there on the worksheet that you have in front of you. Hopefully you have the worksheet shape of things to come there in front of you. I just need to copy out those pictures, and I'm wanting to do a brand new one so that we don't do the one on your worksheet. You can use that as you're in practice. So I'm going to draw a circle. Okay. Sort of, kind of, it's a messy circle, but you get the hint. I will draw it a little darker because it's hard to see. So the circle's kind of like there.
Circle.
All right, and then the next thing that it has is it takes a line from this corner and it goes here, but it doesn't go all the way up. And it wants this piece. There we go. So we need to find the area of that thing, that little shaded piece right there. It gives us information, and I'm going to change the numbers from what you've got on your worksheet.
4, 2, 7. It looks like an F to me. 3.
All right. So those are the only numbers that you're being given. Of course, they're different, and you are being asked for the perimeter of the shaded area, so capital P shaded, and the area of the shaded. All right, let's find, I think in this case the area is going to be the easiest one to find rather than the perimeter. So I need the area of this rectangle square looking piece, and I get that by multiplying the base and the height, or the length and the width. You may have learned it that way as well. So the area of the four-sided figure is the base times the height. In this case, my base is going to be 7. And my height is going to be 4 plus 2, which is 6.
That's easy.
And for 6 times, yeah, I can't talk today. 7 times 6 is going to be, let me pull up my calculator real quick. There it is. So 7 times 6, yes. Oh my goodness, what did I do? I pushed a weird button. I'm so sorry. Give me just a second. Let me get to the menu. Yeah, my hero is not working. There we go. So I need to press menu.
Look, there's a calculator right here.
Yeah. Well, I've got it The reason why I'm doing it on the computer, because of my live studio audience, is I have the calculator actually showing up on screen. Okay, so we're going to go to the calculator app right there. There it is. And now we're going to type 7 times 6. Enter. Thank you, my sweetheart. Thank you. Go have a seat, my lovely girl. Is 42. Oh my goodness. Interruptions galore. Decline. I don't want to talk to you. All right, so the area of the entire rectangle is 42, but I don't want the area of the rectangle. I want the area of the shaded things, which means I have to remove from the total area the area of all the little pieces that are in there. So I have a triangle, so we need to get the area of a triangle. 1/2 base times height. And we need to have the area of a half circle. So you're going to take the formula for area of a circle, which is pi times the radius squared, and you're going to multiply it by 1/2. That's a half circle, not the letter D. All right, so let's look at the let's look at the triangle first.
It looks like a letter D.
It kind of does, but it's not. It's a half circle. The base and the height are the sides that are at 90-degree angles to each other. So one of these is the base and one of them's the height, and it doesn't matter which is which. So 1/2 times the base of 7 times the height of 2. Gonna stick that in my handy dandy calculator. 1/2 times 7 times 2
Times cap lock.
times 2 equals 7. So the area of this triangle is 7, and all of these are given in meters. I forgot to put my measurements. So this is meters squared. Areas are always given in meters squared. All right, so here's
So
the area
two-
of,
So M2 is meter square.
yes ma'am. So here is my
Got it.
circle. I need to find out what my radius is. Now the radius of a circle goes from the center of the circle, which for us was right about here, clear out to one edge, any edge you want. And they're all the same edges. Okay? Since this whole thing was 6 and this piece was 3, that makes this diameter of the circle 3. Half the diameter is a radius, so this is 3 divided by 2, or 1.5. You can write it either way.
What's the difference between a diameter and a radius?
Great question. The difference between a diameter and a radius is that a diameter goes all the way across the circle from edge to edge. That's the diameter, and the radius only goes from the halfway point. So I'm going to trace my little glue stick here so I have a pretty circle. And if I were to cut this thing in half, like half a pizza, whoosh, this would be a diameter from edge to edge and going through the center. Where the radius is going to be just one of the pieces.
Okay.
Awesome. Thank you. That was a fantastic question. All right, so now I have my radius as I can use 1.5, and the radius is squared. So we're going to take that to our calculator. We have 1/2. I know that my live audience, you can't see the calculator, but the recording will have it. Yeah, later. So 1/2 times, and there's a button for pi. What is it, sweetie?
And can I show them the diameter?
You want to show them the diameter again? Let me finish my calculation. 1/2 times pi. Now the symbol for pi is right down here. There it is, and it comes up, and then you'll want to select it. You see me using my mouse because I'm on a computer, but
Alright,
see you later. All right, 1.5, you hit the x squared button, which is right there where my mouse is hovering. There it is. Hit the enter button, and it's going to give you some number. So the area of that half circle is 3.5343. I guess we'll go to 4 decimal places. Meters squared. So that's the area of this piece right in here. So from our 42, which is the area of our total rectangle, we're going to subtract the 7, which is the area of the triangle, and we're going to subtract the 3.5343, which is the area of the half circle, and whatever we have left over is the area of our shaded region. Okay? All right, point out the diameter for us, just so that we can review where the diameter was.
So you know this is what it was again?
The radius?
So you know this yellow part is the radius? That is the diameter.
But only from the edge of the circle to the edge of the circle. So what's inside the circle is the diameter,
So not this part.
not that part. All right, thank you.
Only this.
Only that. Yes, ma'am. All right, thank you very much. The next thing we need to do is find the perimeter of the shaded region. The joys of doing it after school when the child is with us. Yay! All right, we have to find the perimeter of the shaded region. Perimeter means the distance all the way around.
Perimeter is like the outside of something.
That's right, the outside of something. Like if you want to put a fence around your property, you put the fence all on the outside of your property.
So right now my perimeter is 3 desks and, well, a room.
And a room, because that's where she's standing. So we are going to pull this length, which is the same as this, because one of the properties we have from rectangles is that opposite sides are congruent to each other. So since this length is 7, this length is 7. So I'm going to start doing my calculations here. So I have 7 plus this piece right here is 4. I need to figure out what this piece is. I'm not sure what it is yet. So can y'all give me a letter to stand in for this? C. Okay, she wants the letter C. For Carranza, right? Plus C. Then we're going to go here. This is 3. And then we need to find the distance all the way around this half circle. Half of the perimeter of a circle. The perimeter of a circle is called a circumference.
And we know it's a perimeter, but what kind of perimeter is it? Right, Mom?
It's the perimeter of a circle is called the circumference. Did I spell that right?
Circumference.
Perimeter of a circle. So we need a variable for that guy.
A.
A.
A. Yay for me!
Yeah, A for Laura. All right, so that's going to be the perimeter of our shaded figure. So I'm going to go ahead and simplify what I have. Going to collect some like terms, the 7 and the 4 and the 3. 7 plus 3 is 10, plus 4 is 14, plus C, plus A. So I've got to go figure out what those are. The C is going to be the easiest one for me to calculate, so I'm going to do that first. So we can do it over here. C. Whoops, let me slide my workspace up a little bit. Here we go. And let me zoom it in also. All right. So C, right here, this triangle is what kind of triangle? Thank you. Isosceles? Well, I have this angle right here.
Wait, say that again?
What kind of triangle is this?
Is it,
Isosceles.
no, is it right?
It's a right, yeah, it's a right triangle. Yeah, it's a right triangle because it has a right angle in it. And since this is a right triangle, we get to use the Pythagorean Theorem. No, sweetheart, you may not. Thank you.
Okay.
We're going to use the Pythagorean Theorem. Pythagorean Theorem says a squared plus b squared equals c squared. Now, please don't get confused. This a is not the same as this a. Okay? This is the a from the Pythagorean Theorem. This is the a that we made up just right now for this one. Okay. So, a squared plus b squared equals c squared. That's talking about any right triangle where c is the side directly across from the right angle, and A and B are just the other sides, and no one cares what order they are. All right, so if A, I guess this is going to be the short one, this is 2 squared, plus B, the medium one, 7 squared, equals C squared. It just so happened that it was the same letter. And so this is 4, this is 49. I can't add 4 and 49 together in my head, so I'm going to my calculator. Oops, syntax error. All right, 4 plus 49, there it is. 53 equals c squared, so I need the square root of that. The square root button is found by hitting the control button and then the x squared button. There's the square root of 53. Hit enter, and c is 7.2801. We're keeping everything, I guess, 4 decimal places. All right, if you'll hang on to those and show me tomorrow, I can grade
That's
it.
for grade 2.
Yeah, they'll be for grade. Good job, thank you. All right, so that is the measure of this guy. Okay, so I can fix my perimeter equation real quick to add in that. And so now I'm still missing A.
Mommy, pencil, please. Thank you.
All right. So let's go find it. We have a circle. So we're looking for the perimeter of a circle. I thank you, which is called the circumference. We use the big letter C for circumference. That formula is 2 times pi times the radius. That's the formula. We have the radius of the circle already, which is 1.5. So 2 times pi times 1.5. Going to go ahead and go to my calculator and mash the buttons. Going to use the pi button again. Where's that pi button? There it is. And button for pi times 1.5. Enter. And the circumference of the circle, of the entire circle, is 9.424. And I need to round it so the 7 becomes an 8. But I don't want the whole circle. I only have the half circle. So I have to divide this by 2.
I was going to say by half.
Yeah, okay. So saying divide by half would mean divide by half. If you mean you want half of it, you're actually multiplying it by half. Half of whatever is times 1/2. And that's one of those weird language things about math that unless someone sits there and explains it to you, you never really figure it out, kind of thing. So it's okay if it feels weird. So there's my answer divided by 2. Hit enter, and it gives me 4.712. The 3 becomes a 4 because that 9 is bigger than a 4. So then that is my A. So 14 plus that decimal plus this other decimal. And now I'm going to go to my calculator because now there's way too many decimals for me to figure it out. 14 plus 7.201 plus 4.7124. Hit enter, and the perimeter of, yeah, I did that right. Let me make sure I have them all. 7 and 4 and C and 3 and A. Yes. Okay, so I have the perimeter of everything is, you are in the way, 25.9925 meters. And so the perimeter of my shaded 25.9925 meters. Double check to make sure what they want it to be rounded to. If they want it rounded to 1 decimal place, round it to 1. If they want it to the nearest whole number, or 2, or yeah, I'm not sure what it is that I think it's Mr. Gonzalez that this is for. So whatever decimal place he likes it rounded to, make sure you round it to that. But there is the general idea of how you do a problem that looks something like that.
Pretty.
Thank you. We are on to the next one. All right. So the next one's going to be a little more complex than the other one. It's just got more stuff going on and some vocabulary. Yeah, some vocabulary that we haven't talked about yet, even in geometry. Okay. So please bear with me on the the vocab. I will give you as much of the vocabulary as possible.
You're gonna do all of it? Oh, the
Yeah.
whole page?
Yes, I'm going to try to. So this is going to be a long video. All right, so this one, the one you're given is a regular hexagon. I'm going to give it to you as a pentagon. Please trust me when I say that the skill set is exactly the same. Yes, sir? You need a pass. Okay. Please bear with me as I write a pass out. Finish your homework.
Okay.
Thank you.
Mom.
There you go. All right, so I'm just drawing a pentagon. Oh, goodness. I hope it's going to be a pentagon. Okay, it is. It's 5 sides. Oh, my goodness. And the center of it is somewhere in there, like this. Okay, and I think it's going to end up upside down compared to what you had on your, what you have on your worksheet, but, you know, you can use your imagination. I think it's upside down. And it wants the area of the shaded region, so I'm going to color it in yellow, just because daughter is borrowing the pencil. That's okay, I don't need it back. Yellow is pretty. All right, so now we can see the shaded region, and we're told that this thing up here is 12 centimeters. Now, the work I'm going to do, even though I'm using the exact same number and I'm going to use the exact same skill set, everything else is going to change because what you have on your worksheet is for a hexagon. The work I'm going to show you will still work on the hexagon, but the numbers, even though you have the exact same number here, isn't because you have a different number of sides. Once again, you're being asked for the perimeter of the shaded region and the area of the shaded region. Okay, perimeter should be fairly easy to manage. Maybe. I know that if this is 12, okay, I think I have to introduce some vocabulary. This thing is called a regular. On your thing, it's a hexagon. That means it has 6 sides. This thing's a pentagon, so it has 5 sides. The important word here is the word regular. And what regular implies is that all the sides and all the interior angles are congruent. So all of these angles are all congruent. And all of these sides are congruent. Okay, so the perimeter of the shaded region is going to be 12 plus 12 plus 12 plus 12. So 4 12s plus whatever this is and whatever this is. But I'm not giving them, and I can't assume they're 12. Note on the hexagon you probably can, but not on the pentagon. So we're going to walk you through how to find it. I'm not sure what these are. One's going to be X, one's going to be Y, because I don't even know if they're the same as each other. So there's our formula for finding the perimeter, and we got to go figure out the rest. Okay. First thing that we need to do to make this happen is we're going to drop an altitude. That's a line that goes from the vertex of our triangle to the opposite side and hitting at a 90-degree angle. And more than just an altitude, I want this thing to be a perpendicular bisector so that it cuts it into 2 equal pieces. I'm going to cut it down a line of symmetry. And what this will allow me to do is it allow me to create this piece here of 6 and this piece here of 6 and a right triangle right here where I know one of the sides and I can calculate some of the angles. Because if I can do that, I can go to my trigonometry and find the measure of any of the other missing sides. So this is requiring us to remember the trig unit that we did not too long ago. Check out the playlist. There's some trig videos in there. I'll walk you through it also. Okay, so we've got our right triangle. Now let's get these angles. So we have the blue dot angle that we can look at, and we have the green dot angle that we can look at. Let's do the blue dot angle. I think that one's going to be the easiest. In order to find this blue dot angle, we have to figure out the measurement of all these other angles coming in here. Well, I have 5 angles, 1, 2, 3, 4, 5, and they're all going to be the same thing. So I just have to figure out what the angle sum is of a pentagon in order to make this happen. We can calculate it, which we will in our geometry class later, but for right now, since this is an internet and it's a supplement, I'm just going to go to Google and go, hey Google, what's the interior angle sum of a pentagon? I put that in my search bar. It's going to pop it up, and it's going to tell me that my interior angle sum is 540 degrees, and then it goes on to tell me that each interior angle is 108 degrees. So I don't have to do anything more. It gives it to me. Thank you, Google. Please know that we will go over in geometry how to calculate that manually, and you'll need to know how to do it. That's coming up on Friday's lecture, so stay tuned. So this whole thing here is 108 degrees, but I don't want the whole thing. I just want this piece. The thing is this particular line segment that goes from the center of my polygon to one of the vertices of my polygon actually bisects this interior angle. Bisect meaning cuts in half. So this cut 108 in half, and so 108 divided by 2 is something I can't read, 54. So this angle is 54 degrees. Starting to write really tiny, so I'm going to go ahead and zoom it in a little bit so that it's easier to see. There we go. Awesome sauce. So far so good. You're with me? All right. I want to find the measure of this angle right here. Or excuse me, this side right here. I have an angle, and I have the side adjacent to that angle. Looking back at our trig functions, we had the sine of some angle is equal to the hypotenuse, the opposite over the hypotenuse. We had the cosine of some angle being given by the ratio of the adjacent over the hypotenuse. And then we had the tangent of that angle being found by the ratio opposite over adjacent. Since I have a hypotenuse, tangent is out. I'm only looking at sine or cosine. And because I have the side adjacent to the angle, I'm looking at cosine. So that's the formula I want to use to help me calculate this hypotenuse. So the cosine of 54 degrees equals the side adjacent to 54 degrees divided by the hypotenuse of my triangle. Now, the cosine of 54 degrees, you have a trig button on your calculator. It's right there where the arrow is pointing to. Please push that, and it will show you, it's right by the 7. It'll give up a pop-up menu. You'll want to move over to you see the cosine. Click on cosine, and it should already be set in degrees, so 54. When I do this, I get a negative number, so I think that my computer system isn't set to degrees, so I'm going to show you how to set it to degrees in case you get something like this. Negatives are kind of suspect when we're doing these kinds of things. So go to the Home button, press 5 for Settings, 2 for Document Settings, and you want to go to the Angle menu. Please make sure that your angle is in degree. We don't want it in radian, because radian talks about radius. And gradian just sounds like a term you use in art to shade things with. And that's not what we're doing. We're talking with degrees. So make sure it's set to degrees, click OK, and then go back to current number 4, and it'll take you back where you're at. Hit enter again, and it's going to recalculate the last thing you entered, cosine of 54, and it tells you that the cosine of 54 is 0.5, 0.5 8, 7. We'll round it to 8. Go to the restroom then, please. Okay, that's the only change I'm making to this equation at the moment, is just converting that weird cosine of 54 degrees into some number. Okay, I can at this point get rid of fractions in my equation because that's what I have, this rational equation, this equation with a fraction. And since I have one fraction, because any whole number over 1 is the same thing, equals one fraction, I can cross multiply, which is going to make life so much easier. So this thing times this thing. All right, I know this looks like a weird, ugly decimal, and oh my God, that's, just relax, okay? It'll be all right. It'll be all right, all right. 1 times 6 is 6, okay? The goal of solving any equation is to get the variable by itself, so this is the variable you want by itself, so you need to get rid of this number right here. But what's the operation happening between this number and the variable? They're being multiplied. The opposite of multiplication is division, and so you will end up dividing by that weird decimal number. Don't think about it. You're sitting there going, oh my God, I don't know 6 divided by that. You don't have to know what 6 divided by that is. You have a calculator. Go to your superhero. Type in 6 divided by 0.5878. Hit the enter button, and it spits out the number 10.2. I think it's 0.7, so I'm going to round it off to 1. Poof, done. That's why. That's the length of this piece right here. You can repeat it over on this side. However, take a look. This angle. Oops. Sorry. Okay, so that's the length of this side right here. Sorry, I forgot to look at my monitor to make sure that I was in the right spot. Okay, I'm going to zoom in really close on the figure. Super close. Okay. Focus. All right, so we have the measure of this side. We also need the measure of this side, but if you notice, this side is congruent to this side. This angle is congruent to this angle because they're both 90 degrees. And this side, for this triangle, is congruent to this side for this triangle. It's the same line. It's congruent to itself. So by the side angle side theorem, for triangle congruence, these two triangles are congruent, and so if this angle is 54 degrees, so is this one, which means if this side, this hypotenuse is 10.21, so is this side. So now we can scoot down to here and fill in x, 10.21, plus y, 10.21, and I can put that all in my calculator. 48 plus 10.21 plus 10.21 equals 68.42. And I believe this one was given in, our original was centimeters, so there's centimeters, and here is the perimeter of our pentagon. Let me zoom it out. I wrote it in my answer spot. There it is. We also need the area. The area of any polygon, regardless of how many sides it has, is given by the very wonderful formula 1/2, and if you read it on the reference chart, it says little a times big P. And that's all it says. And you're going, great, what's little a, right?
Side.
It's not the side. It's not. And everyone thinks it is, but it's not. This little a is actually a brand new vocabulary word for us. It is called the apothegm. It sounds like you're saying a possum, like a taquach, but you're saying it with a lisp. Apothegm. Apothum.
was TH, not S.
You're right, TH, not an S. So this is apothum. And what the apothum is it's, another word is the in radius. That is the segment from the center to a side at a 90-degree angle. Okay? Back up to our diagram. Here's the center, here's a side, here's a 90-degree angle, there's the line segment that does that. That orange is the apothum, which we have enough information to calculate. You have the option to use either the Pythagorean Theorem or trig. I'm going to show you both in my space down at the bottom right-hand side of my thing. So come down with me, and you'll see I'm about to draw my right triangle again.
Mom?
Yep.
Can I try?
You can copy along with me. Do you want some notes paper? Okay. All right, so I'm looking for this guy, the apothum. I'm going to label it little a as the apothum. We're going to use the Pythagorean Theorem. I'm going to have to write really tiny. And then trig. So here's for Pythagoras. Here's for trig. When we're done, we should see we're going to get the same answer. Here we go. Pythagorean Theorem is a squared plus b squared equals c squared. Hey, we already have an a. And it can be the, now it's not the same a, but we can make it the same a right now because it's not across from the right angle. So a squared plus b squared equals c squared. Yikes. Okay, a squared equals 36 plus 36. All right, and you go to my calculator. 10.21 times 10.21 equals 104.2. All right, I'm going to subtract 36 from that. Oops. So 104.2 minus 36 equals, a squared is 68.2. Yeah. Sorry, my screen got cut off a little bit, so I am having a little trouble seeing all the calculation. There you go. Okay. 0.2. All right, need to take the square root. So, whoa, daughter puts her hand in the screen.
I'm just trying to get the purple marker.
No problem. So square root, and then I can do control, and you see right above the negative sign on your calculator buttons, A and S. If I do control and the negative button, it's going to say answer, which means the answer to the most recent entry you did, which is the 68.2, it saves you having to type it in, which is cool if you're talking about a really big number. So A equals 8.26 centimeters. All right, let's run it with trig. With trig, we want the side opposite the angle. So we are going to use either sine or tangent, because both of those have the opposite. Now on this one, I can use the hypotenuse or the adjacent. Since I calculated the hypotenuse and I was given the adjacent, I actually want to use the adjacent. It'll be more accurate because they gave it to me. And if their number's wrong, it's their fault, not mine. Instead of here, if I did something wrong up this way and this number's off, then everything else I've done up to this point is wrong.
What does accurate mean?
Accurate means exactly correct.
Okay.
Okay, thank you for asking, my dear.
Yeah.
So I'm going to use the tangent to 54 degrees equals the side opposite divided by the side adjacent. Going to go back to my calculator, hit the trig menu by the 7, go over to tangent, click that, and 54. The tangent of 54 is 1.376 equals a divided by 6. I need to get rid of the fractions in that equation. I do that by multiplying everything by the denominator, and so 1.376 times 6 is 8.26 centimeters, which is exactly what I got using the Pythagorean theorem. Now, one is more familiar, the Pythagorean theorem, because you've been doing it since, like, what, the 5th grade?
Mm-hmm.
And one is new, trig. But look how much fewer steps is involved. Neither one is correct over the other. They're both the right way to do it. Neither one is better than the other, except what's easier for you and what information you have. If you've got two sides, go for it. Pythagorean theorem, everyone's happy. You only got a side and angle, trig. All right, so now that I have my apothegm right here, apothegm.
Not with an S, but with a TH.
But with a TH, and I have my perimeter from before, I get 1/2 times the apothegm, which we calculated 8.26, times the perimeter, which we oh wait, this perimeter was not the perimeter of the polygon. That was the perimeter of the shaded region in my polygon. Uh-oh, so I've got to find my whiteout. Where is my whiteout? It has disappeared. Oh, here it is. It was behind me. If it was a snake, it would have bitten me. All right, so I need to get rid of that. I need the perimeter of the polygon. Come up with me to the top of the page. All right, there's my polygon. Perimeter of the polygon. 12 times 12, not times, plus. 12 plus 12 plus 12 plus 12 plus 12. 1, 2, 3, 4, 5 12s. I can shortcut that as 5 times 12. That's the same thing as 12 added to itself 5 times. 60. I did in the calculator. Studio audience didn't see, but those of you at home totally got to see me playing with the calculator. So this is 60, not 68. So going to go back to the calculator and calculate all of that. Yes, lovely girl. As you stick your arm in front of the screen again.
I was gonna tell you that I was gonna do that again, so.
But too late, you just did it. All right, so stick it in there, and the area of the shaded region of the polygon is 247.8 centimeters squared. And that is how you would calculate that. I know, it looks like I'm going to zoom out and you're going to see this whole page. It looks like a hot mess.
Do it, zoom out, zoom out.
And it really kind of does look like a hot mess.
Focus. There we go.
The important vocabulary was this word regular, meaning that all the sides and all the interior angles were equal. And this formula, in which you said that the little a was the apothegm, and what the heck that meant, and that this big P was the perimeter of the polygon, not of the shaded region that you calculated before. Yes, my dear.
What does Papa mean?
Apothegm, I don't know, but apothegm is the in radius, the segment that goes from the center of your polygon to one of its sides and hits that side in a 90-degree angle.
Polygon, what's a polygon?
Great question. Would you like to give a shot at the answer while I shuffle my papers?
Is it let me guess. It's closed. It's just a type of shape with the last name of Gon and the first name of somebody.
That's a fantastic guess. What were you going to say, my dear?
A closed figure with at least 4 sides.
What's the characteristic of the sides? Are they all curvy or are they all straight?
Straight.
Beautiful. Yeah. So it's any closed figure, like a pentagon, that has all straight sides, and you want 3 or more of those, because if you have 2 sides, it doesn't close. At least not in 2 dimensions. It might somewhere else, but we don't know that yet. Okie dokie.
Guys, we're gonna call 2 dimensions 2D just so you know for short.
To shortcut it.
Yes.
Okay.
Shortcut.
Shortcut.
Whoa, whoa,
We're on to the shortcuts. Okay, I don't know where my big bold pen ran off to. It has, oh, it's right there.
I'm holding it.
You were using it.
Oh, this one.
Yeah.
Sorry.
That's all right. Okay, we're going to quickly look at D and at E, and I'm going to actually show you the worksheet that I have on it. There is D. Talk about what kinds of things you can do to find D. You want the shaded region. What's the biggest shape?
The circle.
The circle's the biggest, so that's the total area. Thank you, phone. And then the unshaded is this little tiny rectangle in there. Do you have enough information to find the area of the rectangle? You think so, because this is probably the measure of this, and this is probably the measure of this. So base times height. Yay, we're happy. What we don't have is the radius of the circle, which we need to generate the perimeter of the circle, the circumference, and the area of the circle, which we need so that we can get rid of the thing that we don't want, which is that radius, the rectangle. So that's what we need to take time to work on. And I'm saving, you notice I skipped one. I'm saving that one for last just because it looks the most complicated. It's not, but it looks that way. Okay, gonna bust out the compass again, if I can remember where I put it. Here it is. And the pencil, if I can remember where my daughter returned it to. I don't remember.
It's on the desk.
It's on the desk. I don't see it.
There's one here.
Oh, there's one there. You know what? I'll take it. And it's beautifully sharpened.
Yeah.
Yay! Jackie, I'm using your pencil.
Alright.
All right.
I was actually gonna kind of say something. I was gonna be like, hey, you're welcome.
Hey, thank you. All right, so I'm gonna make this. I'm gonna zoom out and just pick my camera up a little bit so that I have room to work. Okay, now I'm not gonna move my compass. I'm actually gonna move the paper because every time I move my compass, bad things happen apparently. So just gonna turn the paper around, holding the compass perfectly still. And when I do that, I have a much better shot at making like an actual circle that closes. Ta-da! Ta-da! Okay, there, my circle closed. Yes, my dear.
Try a circle without a compass.
Yeah, no.
Do it.
No, they're not circles. They end up being amoebas.
Do it.
All right, now I need, here's my ruler. Oh, this video has run very long. It has been like 45 minutes. Yep, and we gotta get home before Dad gets upset. Well, because he's cooking dinner, okay? And this totally doesn't look like a rectangle. It looks more like a trapezoid. But we're going to pretend it is a rectangle, and we're going to do that by calling these 90-degree angles even though they don't look it.
Caution, you're going to see hand on the screen. You might.
You might see him on the screen. Oh, you did it without showing. Awesome, good job.
I tried.
All right,
But it's fun.
we need the radius. You know what? It totally looks like this rectangle is centered on the circle. At least on your worksheet. Not here. So halfway from here to here and halfway from here to here should give us this measure. What we're missing is all of this. All right. Tune in next time because one, it's late and this video is like already a bazillion years long. And two, I need to think about how to do this one a little bit more and maybe draw it better because that is hurting my brain. You want to show? Okay, picture from my daughter. Yay! It's so pretty. Thank you very much. If this video helped you out, how am I supposed to say it? My young daughter's a YouTuber. How am I supposed to say it at the end of the video? How do I close the video?
From which YouTuber?
Anyone. Your favorite. If the video helped you and you liked it, mash the like button.
Oh, Sandy.
Sunday, yeah. And don't forget to hit the subscribe. Just so that you can get notifications of the next time I decide to do a lecture, which is Friday. Friday, there's lecture in class. Okay, bye.
So pretty.